Okay, we'll start our class now. Already 1:38. Good afternoon, students.
Good afternoon, ma'am.
Okay. So just we'll discuss reverse osmosis method, ma. Okay. We'll complete now. Module 2. So this method is applicable mainly for the desalination of seawater, ma. Okay. So what we are taking here is, I have to draw this diagram. So we are taking here two chambers here, okay, or one chamber, and we are separating here. We are taking the semi-permeable membrane. So semi-permeable membrane, it is made up of cellulose acetate, or we can take semi-permeable membrane. It is also known as superior membrane. So we will take polyamides, polymers, polyamides, or polymethacrylate. Polymethacrylate, this is also polymer. Okay, so this we will use as a semi-permeable membrane. So we are taking here on the upper chamber, we are taking brackish water, or it is called sea water, and lower chamber we are taking a pure water, and we are separating with a semi-permeable membrane, and we apply the pressure, okay, on the higher concentrated side solution. We are applying the pressure, okay, so that the flow of solvent takes place, okay, from higher concentration to lower concentration. From higher concentration to lower concentration, the flow of solvent takes place. So we can see here, the reverse osmosis cell consists of a chamber fitted with a semi-permeable membrane. So above which we will fill with the seawater, impure water is taken, okay, na? And pressure of, how much pressure we are applying is 15 to 40 kg per centimeter square pressure is applied. 15 to 40 kg per centimeter square pressure is applied on the seawater for separating the water, that is pure solvent, from its contaminants. So if what all the solute particles are present in salt water, so that will be remaining in here first chamber, okay, in upper chamber, and only flow of solvent takes place through the semi-permeable membrane. Only flow of solvent takes place through the semi-permeable membrane, where we get the pure water. So that pure water we will use for domestic purpose and industrial purpose. And now here the semi-permeable membrane, it does not allow the passage of dissolved solute particles. It does not allow the passage of dissolved solute particles, but it will allow the flow of solvent, means water. So this process is very easy, and it is used to make pure water. And here, by this process, it removes ionic and non-ionic substances in water. It can also remove suspended and colloidal particles. And this life of the membrane, semi-permeable membrane, we can use up to 2 years. Up to 2 years, we can do the process. So we can purify the water. Okay. So after 2 years, that semi-permeable membrane, it is replaced by, means we can take out that one, we can take fresh semi-permeable membrane. Okay. So by this process, reverse osmosis process, by this process, so we can get pure water. We can purify the water, means from the sea water we can get the pure water, so that we can use for drinking and for industrial purpose also. Okay, water obtained after treating reverse osmosis process, it is used in boilers. In high pressure boilers also we can use. Now here you can see osmosis process. We know that is the flow of solvent takes place from higher concentration to lower concentration to higher concentration, lower concentration to the higher concentration through semi-permeable membrane. That is the osmosis. Whereas reverse osmosis means we have to apply the pressure, we have to apply extra pressure, we have to apply on the higher concentrated side, solution side. On the higher concentrated solution side, we have to apply the pressure, so that flow of solvent takes place from higher concentration to lower concentration. Higher concentration to lower concentration. Now, what are the advantages means? By this process, already I told you, removing ionic as well as non-ionic dissolved salts easily. So we can remove colloidal impurities, for example, silica oxide, okay? And this process is economical and convenient process, okay? So this setting of this process, what we are buying semi-permeable membrane, it is also not more cost, okay? So this arrangement is very easy, okay? It is simple, okay? Convenient process, economical. So the process can be carried out at room temperature, okay? So this is the advantage. It is suitable for converting seawater into drinking water. That already we know, okay? So by taking seawater, we can get the pure water by this reverse osmosis process that we can use as a drinking water. So this water can be used in high pressure boilers. This water can be used in high pressure boilers, okay? This soft water. So these are the advantages. So we can remove colloidal impurities, we can remove ionic or non-ionic dissolved salts, and this process can be carried out at room temperature. It is economical, the process is economical and convenient, and we will get pure from seawater, we can get the pure water, which is we can use for drinking and industrial purpose. And this water is used in high pressure boilers. Now applications are treatment of wastewater. We can take wastewater and we can go for reverse osmosis process, going for desalination process, removal of salt NaCl from the seawater, desalination process, and the purification of water, like this after purifying the water, that soft water we use for dialysis and hospitals. Hospitals we use RO water, and for certain cosmetics we use RO water, and drugs, okay, by pharmaceutical manufacturers, means we are using in pharmaceutical industries also RO water, and also water for injection, okay, for injections also we need water, no, that water also we can use RO water. So these many applications are there, we are using in everywhere. Industries we are using hospitals, pharmaceutical industry, and we are using for domestic purpose, drinking, okay? So here very good applications are there by reverse osmosis process. So students, you have to write here, no need this explanation, osmosis also no need. You write from here, what is the principle of reverse osmosis, and you write, take this diagram and explain the method, okay? Explain the method, this one, this slide and this slide method, okay? So then you can write advantages and applications. So simple topic this one, okay? Reverse osmosis. So tell me students, what is osmosis? What is osmosis? What is osmosis, students?
Solution flowing from higher concentrations.
Not solution.
Solvent.
Not solution. Solution contains both solute and solvent.
Solvent moving from lower concentrations to higher concentrations.
Solvent moving from lower concentration to higher concentration by osmotic pressure. Yes, sir.
In the presence of a semi-permeable membrane.
Through semi-permeable membrane. Okay. So what is reverse osmosis? Reverse osmosis. Reverse osmosis.
Solvent moving from higher concentrations to lower concentrations.
Solvent moving from higher concentration to lower concentrated solution through
Semi-permeable membrane.
semi-permeable membrane by
applying pressure.
Pressure. By applying pressure. By applying pressure. That is should be greater than osmotic pressure. Okay, ma. So that here we have to apply compulsory pressure, so that only we can flow the solvent from higher concentration to lower concentration through semi-permeable membrane. So what is the function of semi-permeable membrane here? What is the function of semi-permeable membrane?
It does not allow the passage.
It does not allow the
Solute particles.
Solute particles. It allows only
Solvent particles.
solvent. It allows only solvent particles or solvent molecules. It does not allow solute particles, so that we will get the pure water. Okay, that is solvent H2O. Understood, ma? Okay, what are the applications, ma? Where we can use RO water?
In normal processed water, dialysis, and pharmaceutical industries.
We can use in hospitals, okay, pharmaceutical industries, and high pressure boilers, okay, high pressure boilers, and for drinking purpose we can use. Understood, ma? Okay, so there are some applications are there, you can write. We are using in high pressure boilers. We are using in high pressure boilers and drinking water, and also we are using in hospitals, pharmaceutical industries. Means we are using in hospitals, pharmaceutical industries, drinking water and boilers. Okay, so either for domestic purpose we are using RO water, and also for industrial purpose also we are using RO water. So by this process, reverse osmosis, what is the advantage? What is the advantage? What is the advantage? If they will ask you to write the advantage of reverse osmosis, what you will write?
It
By
removes
this process, what we can remove?
ionic and non-ionic
Either
salt,
ionic or non-ionic dissolved salts we can remove, and also
colloidal
colloidal
impurities.
impurities we can remove. Okay. Next advantage.
It is economical and
Is
convenient.
economical and convenient process, yes or no? Okay. So semi-permeable membrane, how many years we can use?
Up to 2 years.
Up to 2 years we can use. Okay, so after 2 years we can replace, but up to 2 years we can go, we can do the process, no? Yes or no? Yes or no?
Yes.
So this process is economical and convenient. This process is economical and convenient, and it can be carried out at room temperature, and it is suitable for converting sea water into drinking water. The people who is staying near the sea areas, for them it is useful, yes or no? Those who are not getting drinking water, the areas near the sea areas, villages will be there. So many villages, yes or no?
Yes, ma'am.
Okay, ma. For them it is like very good application. No? Means they can use the they can follow this reverse osmosis process. No,
Yes, ma'am.
they can go for planting. No, yes or no? RO plant. Students. This is very simple process, ma, and we can purify the water. We can get a drinking water. Okay, so in industries we can use, and in for domestic purpose we can use. See, for hospitals also we are using. For hospitals also we are using. For dialysis in hospitals and pharmaceutical industries, drugs, cosmetics, injections, everything we are preparing with the RO water. Okay, ma. This is about reverse osmosis process. So we completed module 2, ma. Module 2 we completed. We discussed topics already, you know. This treatment methods, how many we discussed, ma? Treatment methods, how many we discussed? How many topics? Treatment methods.
Like ozonation.
No. Treatment methods. One is ion exchange process. Ion exchange process, no? Treatment method. External treatment method, ion exchange process. Second topic, potable water and its treatment. Potable water treatment method. Okay. Third is reverse osmosis method. How many we discussed, students, in module 2?
3.
3, ma. Ion exchange process, potable water treatment method, and reverse osmosis method. Okay. And next one, in hardness of water, we discussed types of hardness and units of hardness, calculation of hardness, EDTA method, estimation of hardness of water by EDTA method, that is total hardness, permanent hardness, temporary hardness, and problems on EDTA method. Problems on EDTA method. So these are the topics. Okay, you have to prepare. Long answer questions are EDTA method. EDTA method, ion exchange process, and potable water. 3 are long answer questions, remaining short only. Following me?
Yes, ma'am.
Total 5 theory questions are there. Types of hardness, units of hardness, you can read it. That is simple only. EDTA method, ion exchange process, potable water, reverse osmosis. So these topics, theory topics you have to prepare. After that, you can learn the problems, hardness problems and EDTA method problems. Okay, na? Okay, ma? Understood everybody? Module 2? Students? Okay, ma. So we will start now module 3. Ma. Module 3 is very simple. That is also, we will discuss polymers. Ma. You are not writing in your notes now. You will see the PPT. You will follow the PPT.
Yes, madam.
Yes, ma'am.
Yes, ma'am.
Students, now you write down module 3 in your notes. Start fresh page. Module 3, engineering materials. Module 3, engineering materials. Out of 65 students, only 54 are there. Where are the others? Module 3, engineering materials. Okay, ma? Module 3, engineering materials. Now students write down what we are going to discuss is, in module 3, we will discuss polymers. Ma. Polymers, write down. We will discuss polymers. We will discuss polymers, rubbers, and lubricants. Write down. What we discuss in module 3 is polymers, rubbers, and lubricants. Polymers, rubbers, and lubricants. Okay. So we'll discuss first polymers. After completing polymers, we'll discuss rubbers and lubricants. So for mid-1 exam, you are having up to polymers only. Rubbers and lubricants, that is elastomers and lubricants, we'll discuss after mid. Okay.
Okay, ma'am.
Now I will give introduction about polymers. Just I will give you introduction. After introduction, we will discuss the topic. We can start the topics. Okay. So what we discuss in polymers is, we will discuss here types of polymerization. Types of polymerization: addition, condensation, and copolymerization. Types of polymerization: addition, condensation, and copolymerization. Then we will discuss here plastics. Difference between thermoplastic resin and thermosetting resin. Compounding of plastics, one topic is there, compounding of plastics. Then we will discuss preparation properties and applications of polyvinyl chloride, nylon 66, bakelite, Teflon. Polyvinyl chloride, Teflon, nylon 66, bakelite. So 4 we will discuss. Okay, now preparation properties and applications. After completing that 4, we will discuss biodegradable polymers. Biodegradable polymers. So this is the portion we are having. Okay, for mid-1. First, types of polymerization. Second topic is difference between thermoplastic, thermosetting resin. Third topic is compounding of plastics. Fourth topic is preparation properties and applications of nylon 66, Teflon, polyvinyl chloride, bakelite. And next we will discuss biodegradable polymers. So today we will discuss polymers, classification of the polymers. So this introduction part only. Students, you are following me? Introduction only, classification of polymers. Then topic is what we have to discuss. The topic is polymerization, types of polymerization. Types of polymerization. So that is the first topic. Okay. Now, polymers in the 15th century itself, the scientist Christopher Columbus, in the 15th, now which century we are living? Which century we are
21st
now?
21st century, ma'am.
21st,
Ah,
in the polymer, it is invented in 15th century only. In the 15th century, Christopher Columbus, scientist, he noticed that the natives of South America, they were playing with the bouncing balls. That is made up of, the ball is made from the latex of a tree, natural rubber. Okay, so like we can take our India, in Kerala, rubber trees will be there. Okay, Hevia brasiliensis name. So we collect latex from that tree. So there also in South America, they are playing with the balls that is made by latex of the tree. Latex means white milky liquid. Okay, they are playing with that ball. So which is used to call weeping wood. Okay, flowing that white liquid. So this natural rubber, which was named by another scientist, Joseph Priestley, as rubber. Why he have given the name is rubber means because as it is erasing the pencil marks from paper. Okay, as it is erasing the pencil marks on the paper. So Joseph Priestley, he gave it as a rubber. Okay, so this polymer invented in 15th century only, but name is given by Joseph Priestley. Now next, in 1909, later on in 1909, this scientist, Leo Beckland, he developed one polymer. He developed the phenol formaldehyde resin. The name is given Beckelite. Phenol formaldehyde resin. Name given is Beckelite. So he prepared this by taking the eraser are made from latexa. Latexa. What, ma? What you are telling? Yes, ma. Yes, okay. Now this Beckelite polymer, it is prepared by taking the chemicals phenol and formaldehyde. So two chemicals, the scientist used two chemicals, phenol and formaldehyde. Okay, he prepared Beckelite. So he has been called now the father of plastic industry. So in 1909, Leo Beckelite, he prepared phenol formaldehyde resin, so that we will use in our house. Switches will be there, switchboard. So that is made up of by the Beckelite. The Beckelite only. Okay, we will make switches and switchboard and all. Okay. So this scientist, he invented that Beckelland, that is Beckelite phenol formaldehyde resin. So he is called father of plastic industry. This scientist. Next, polymers. It is very important components in our daily life, because you can see in your home. Okay, we are using the polymers, bottles or any cups or any plates, buckets, chairs. Okay, we are taking plastic. Okay, we are using polymers in our daily life. The polymers are highly useful in domestic and industrial and medical field also. So that nowadays, without that we can't live. Okay, means we are using more plastic now. So the polymers are highly useful in domestic purpose, industrial purpose, and medical field. So why means some uses are there. What are the extensive uses of polymers are? Most of the polymers are non-toxic and safe to use. They have low densities, light in weight. Okay, you take iron bucket and plastic bucket. We prefer plastic bucket only because it is light in weight. We can use it. Okay, so light in weight. So transportation of polymers will be very easy. So they possess high strength. The polymers are having high strength. We can use more period of time, high strength, okay? Good flexibility. They do not break also. High strength, good flexibility, resistant to chemicals, So these can function as good thermal and electrical insulators. This can function as good thermal resistance to heat, good thermal and electrical insulators. So these can be molded and fabricated easily. We can mold into any shape. Okay, no? They possess aesthetic colors. So we give pleasant colors to the polymers. No? So when you go to the shop, I don't know whether you will see the quality of the plastic or not. Maybe by looking at the color also, some people will buy. Yes or no, students? When you go to shop, what you will do?
Quality we will see that.
You will see quality only. Definitely. Or you will see the color and buy.
Quality.
Quality you will see, not color.
Color only, ma'am.
Color only.
Price.
You won't see quality of the plastic, huh?
Quality.
Yes, ma.
Quality is important, ma'am.
Quality only you will see, not color, no?
Depends on price, ma'am.
Depends on price, huh?
Ma'am, first we'll buy Tupperware will buy.
Huh? What you
Tupperware
will
plastic.
see?
First it is quality, ma'am. Second is color.
Color, huh? Okay. If color is not good, quality is there, you will buy, huh?
No, ma'am. After that, we'll paint it at home.
Appa, you will paint it at home, huh? Okay. Polymers are used in homes, vehicles.
Ashraf has painting industry, ma'am.
Huh?
Ashraf has
What?
painting industry, ma'am.
Okay. Okay, listen now. Polymers are used in homes. Already I told you, and vehicles also. It is used to repair organs also, means medical field also we are using. It can be used in purification of water. Okay, purification of water also we are using. So these are used for furniture, fabrics. So many uses are there, but I gave only few. Okay, na? Polymers. Now, we know that the polymers, it is a Greek word. Okay, in Greek, poly means many and mers means units or parts. Okay, poly means many. We cannot tell that is 100,000 or lakhs. Just we will write. We will write that here. You can see, and we will write many. Poly means many. Mers means units or parts. So polymers can be defined as a large molecule. It is a large molecule, macromolecule, large molecule formed by linkage of small molecules, formed by linkage of small molecules called monomers. Now here ethylene, it is a monomer. If you take only one ethene molecule, it is a monomer. It is a monomer. Taking number of ethene molecules together and linking together, adding together, we get a polyethylene. Means we'll get a polymer. Okay, polyethylene. So before the monomer, we write polymer. Before the monomer, we write poly means many. Okay, so polyethylene. Okay, so this is the polymer, not this is the polymer. Okay, this is the monomer. We are taking a number of monomer molecules combined together, means adding together, linking together by applying heat pressure catalyst. By applying heat pressure catalyst we use benzoyl peroxide. Okay, na? And we'll apply some heat and pressure and we'll prepare the polyethylene. Polyethylene. You can see here monomer, it is a single molecule. Polymer, it is a chain of monomers. It is a chain of monomers. But monomer is a single molecule. A polymer is a chain of monomers. We are linking together. A number of monomers we are linking together, obtaining a polymer. Obtaining a polymer or preparing a polymer. Okay, na? So what is polymer? Polymer means, poly means what? Poly means what?
Many.
Many. Mers means what?
Units or parts.
Units or parts. What is the unit or part here? Example, tell me.
Monomer.
What is that monomer here? What is the monomer here? Ethylene. Okay. Monomer is ethylene. Okay. Polymer is?
Polyethylene.
Monomer is ethylene. Polymer is?
Polyethylene.
Polyethylene.
Ethyl.
Okay. So this is example we have taken. I gave one more definition also here. So a polymer is a long molecule or large molecule formed by joining together of thousands of small molecular units by chemical bonds. Due to their large size, they are also sometimes called macromolecules. Okay. So polymers are macromolecules built up by linking together of large number of small molecules. So this definition you can write. What is polymer means? Okay. A polymer is a long molecule formed by joining together of thousands of small molecular units by chemical bonds. Okay. So poly means that is many. It is used before the name of the monomer. It is used before the name of the monomer or compound, indicating the compound to be a polymer. Examples: polyethylene, polystyrene or styrene. Polystyrene, students. Polybutadiene, okay, etc. are polymers formed from monomers of ethylene, styrene, butadiene. Okay, so before that, before the monomer, we are writing poly, so that is the polymer. Okay, indicating the polymer. So here I gave some natural polymers, my examples like proteins, enzymes, carbohydrates, DNA, RNA. So these are also some examples I have given, natural polymers. So here this already, bottles, straws, okay, some plates, cups, all these are polymers. Okay, made up of, means we are taking a plastic. For example, you are taking a polyethylene and preparing a bottle. Okay, na? So these are polymers. Now, here, the number of repeating units in polymer chain, that is known as degree of polymerization. Okay, if you take 100 molecules of ethylene and go for polymerization, means preparing a polymer. So that is known as, here degree of polymerization is 100. If you are taking 1000 molecules and degree of polymerization is called 1000. Okay, so based on that, here we take, not based on this is separate only. Types of polymers are two types. Homopolymers, copolymers. Homopolymers means we'll take same type of monomers, same monomers. Copolymers means we'll take different monomers. So polymers made up of only one type of monomer. For example, polyethylene. So that is a homopolymer. Homo means what, ma? What is homo?
Same.
What is homo? What is homo?
Same.
Same. What is co?
Different.
Different. Co means different. So what is the example of homopolymer, ma? What is the example of homopolymer?
Polyethylene.
Polyethylene. We are taking here same monomers, yes or no? Okay, n number of ethylene molecules we are taking and we are getting polyethylene. So this is a example of homopolymer. So there are three here. We are dividing into three types here. Okay, straight chain polymers, branched chain polymers, cross-linked polymers. So straight chain polymers means you can write polyethylene, like a long chain you will get. Okay, straight chain polymers. So branched chain polymers means you will get branch like, okay, here like a branch you will get. Cross-linked means you will get here cross-linked structure. So here there will be three, okay, straight chain polymers, branched chain polymers, and cross-linked polymers. And next is copolymers. So copolymers means we'll take different monomers. Okay, M1 is one monomer, M2 is one monomer. Okay, for example, you can take butadiene and bunaious rubber. Bunaious rubber, we will take here butadiene and styrene. Okay, different monomers will take. Okay, Na is sodium. We will use as a catalyst. So here monomers are butadiene and styrene. In preparation of bunaious rubber, we use butadiene and styrene. Okay, so two different monomers we are taking. So polymers formed by the reaction between different monomers, that is known as copolymer. So here also it will be dividing into three types: straight chain polymers, branched chain polymers, and cross-linked polymers. Okay, so this is like introduction part. So this no need for you, ma. I am not telling here about this straight chain, branch chain, cross link. For you, no need. Only I want to tell you about what is homopolymer, what is copolymer. So I didn't give you in PPT because this is only introduction. No? So classification of polymers, ma, there are polymers are classified into natural polymers, okay, synthetic polymers, and semi-synthetic polymers. Natural polymers, synthetic polymers, semi-synthetic polymers. So natural polymers, like example, you can take inorganic polymers, ma, clay, silica. Organic polymers, you can take cotton, wool, silk, cotton, wool, silk, that are polymers, organic polymers, natural polymers. Synthetic polymers means we prepare man-made polymers, okay, artificial. Synthetic polymers, that is also three we are taking. Elemental organic polymers, silicons, okay. For example, silicon rubber we will make. Understood, ma? Okay, silicons. Inorganic polymers, polycarbonates. We will use carbon, boron, okay, and hydrogen. We will prepare the polymer. Okay, organic polymers. This polymer which is having as a carbon as a backbone of this polymer. Backbone of the polymer that is made up of the carbon. So that is known as organic polymers. Okay, na? But we will discuss only organic polymers. In this module, we will discuss only organic polymers, not inorganic polymers or element organic polymers. We will discuss only organic polymers, that is backbone of the polymer made up of carbon. So organic polymers, what we are going to discuss in this module is, we will discuss plastics, thermoplastic and thermosetting plastics. Rubbers we will discuss, natural rubber and synthetic rubber, and fibers like nylon 66. Okay, na? Next, semi-synthetic polymers are there. Third type is semi-synthetic polymers. I told you three types are there. Polymers based on their origin and nature. Polymers are three: natural polymers like cotton, wool, silk, clay, silica. Synthetic polymers, you know already. And semi-synthetic polymers also is there. That is cellulose derivatives we will get from the plants, wood, cellulose derivatives. For example, cellulose acetate, like a rayon clothes. We can manufacture rayon clothes, semi-synthetic polymer. So this is about classification, introduction. Okay. See, based on origin, three types. Based on origin, three types: natural polymers, synthetic, semi-synthetic polymer, synthetic polymer. Natural, you can take cotton, silk, wool. Semi-synthetic, you can take cellulose acetate. You can take synthetic polymers like nylon 66, polyvinyl chloride, bakelite. You can take. Based on structure, three types will be there. Structures will be linear polymers will be there, straight chain, branched chain polymers will be there, and cross-linked polymers will be there. Okay, for example, bakelite. Bakelite is cross-linked polymer. Okay, polyethylene is it is a straight chain polymer. So three will be there based on the structure. All the polymers are not straight chain. All the polymers are not branched chain. Depend on polymer. Okay, based on their structure, it will be three types. Based on molecular force, elastomers are there, fibers are there, thermoplastics are there, thermosetting polymers are there. Elastomers means rubbers, fibers, thermoplastics are there, thermosetting polymers are there. Okay, plastics. Based on polymerization, there are two types are there: addition polymerization and condensation polymerization. Okay, so by addition polymerization, some polymers we get; by condensation, some polymers will be obtained. So this is like a classification of polymers, students. So this no need for you, because I didn't give any question also, because this is introduction part. So just I gave in this PPT, I am telling again, and just I gave about uses one here. Okay, and what is polymer I gave here, polymer and definition and example. Next, homopolymer, copolymer. Next, classification: natural, synthetic, semi-synthetic. This part. Okay, na? So, but the topic starts for us in polymer is this is the topic. Okay, types of polymerization. Students, you are following me?
Ma'am.
Students,
Yes,
you are
ma'am.
following me? Okay.
Yes, ma'am.
So you write this topic now. Polymerization, write down. Write down polymerization. Polymerization, write down. Polymerization. The process by which simple molecules are converted into polymers. Simple molecules are converted into, you can write large molecules. Simple molecules are converted into large molecules, you can write. Okay. Simple molecules are converted into large molecules. In bracket, we write polymers. Okay. So that is known as polymerization. Okay. So what is polymerization means? It is the process. Polymerization is the process. Okay, na? It is the process by which simple molecules, in bracket write monomers. In bracket write monomers. Simple molecules are converted into large molecules. Simple molecules are converted into large molecules. You write one more sentence also. By applying heat, comma pressure and catalyst. You write this one. This is important. What is polymerization means? By applying heat, pressure and catalyst is called polymerization. Tell me, students, what is polymerization? What is polymerization? It is the process. Students.
By which simple molecules are converted into large
Simple molecules are converted into large molecules by applying
heat,
pressure and catalyst is called polymerization. So we are preparing a polymers from the monomers by polymerization process, that is by applying heat, pressure and catalyst. Okay. So this process is known as polymerization. Here write more types of polymerization. Types of polymerization. Types of polymerization: addition polymerization, condensation polymerization, copolymerization. Okay, next class we'll discuss more this one. Okay, now types of polymerization we'll discuss in next class. Students understood my class? Huh? Hello?
Yes, ma'am.
We'll discuss in next class types of polymerization. Shall I end the class?
Yes, ma'am.
Okay.
Yes, ma'am.
Okay. Today I have given only introduction part, polymers.